Hello students, this is your very new subject which you haven't heard about. Till date you have heard about English, physics, chemistry, mathematics, but this is a very new name, applied mechanics. So, being a student of engineering, though it is mechanical or civil engineering, this is a very new subject and this is probably your entrance to the world of engineering. This is applied mechanics. What is mechanics? Mechanics is a branch of science which deals with study of forces and their effects on body in motion or at rest. In physics, we have studied different laws of motion which are known as Newton's first law, second law and third law of motion. In all these three laws, the action of forces or action of force is much important. In that way, applied mechanics is a next part of subject physics. Because in applied mechanics, you have to deal with forces, action of force, study of forces and their effect on bodies in motion or at rest. Just now we have seen what is mechanics. Now what is applied mechanics? Application of this knowledge in real practice is known as applied mechanics. Or definition of applied mechanics is that a study of different laws and principles of mechanics applied to the engineering problems is known as applied mechanics or simply engineering mechanics. In that, we have to study static and dynamics. Static means what? Action of forces when body is at rest. Suppose one object is there and you are applying a force to the object and the object is moving. See, this is the object and this is a static object and I am applying a force and it is moving. So, this is the application of force. So, static is action of forces or a force when body is at rest. What is dynamics? Action of forces on bodies which is at a motion, which is moving. Dynamics is again further classified into two main categories. The first one is kinetics. Kinetics is study of branch of dynamics which deals with action of forces on bodies in motion considering mass of the body and forces causing motion. This is known as kinetics. And what is second? It is kinematics. It is that branch of dynamics which deals with action of forces on bodies in motion without any consideration of mass. Kinetics is considering a mass. Kinematics is without any consideration of mass of the body and forces causing motion. This is kinematics. Now, before going to the quantity force, we have to study some basic quantities, basic physical phenomena in order to study this mechanics. So, the first we have to study differentiation between the mass and weight. Weight is a misnomer. When someone is asked, what is your weight? Then you tell the person that I am weighing 60 kg, but actual 60 kg is your mass, not a weight. Mass is a scalar quantity and weight is a vector quantity. We will study what is scalar and what is vector, but before that let us differentiate between mass and weight. Mass is a quantity of matter contained in a body. What is weight? Weight of a body is the force with which the body is attracted by the earth towards its center. So, when someone is asking your weight, it is literally what he asked, but what you tell is not a weight, it is a mass. It is a mass is a scalar quantity and weight is a vector quantity. Unit in SI is kg for a mass, and for a weight it is in the Newton. Mass of a body remains constant at all places, for example on earth or moon, etc. But it is unlike weight. Weight of a body changes from place to place. Then what, on which quantity weight is depend? So weight is depend on G, center of gravity, G on earth, G on moon. So it is depend on gravitational acceleration, gravitational force of that place. So basically we are on earth, so weight of a body changes from place to place. If we are talking about weight of person on earth, then gravitational force of earth must be considered in that case. So for example, on earth, weight is mass into gravitational force on earth, and the answer would be in Newton. So on moon, a person's weight must be mass, which is constant everywhere, mass into gravitational force on moon. Suppose we have to take a weight of a person on Venus, then we have to consider m mass into gravitational force on Venus. So this is a basic difference of mass and weight. So what is scalar quantity? A physical quantity having only magnitude but no direction, it is known as a scalar quantity. And what is vector? A physical quantity having magnitude and direction both is known as vector quantity. Scalar quantities can be added or subtracted by usual arithmetic operation, but unlike vector quantities can be added or subtracted vectorially and not arithmetically. Scalar quantity examples: mass, area, volume, density, time, speed, temperature, work, power, energy, etc. And for example, it is a displacement, velocity, force, weight, momentum, moment, acceleration. In short, for vector quantity, that indicates a motion. In order to study mechanics in detail, we have to learn first some basic principles, or we have to revise some basic principles till date we have studied. The first one is Newton's laws of motion. There are three laws. Newton have derived three laws of motion, which are very basic requirement for studying engineering mechanics or applied mechanics. Every body, the first law, let us write down the first law. Every body continues to be in its state of rest or of uniform motion in a straight line unless it is acted upon by some external force, that is known as first law. What is second law? Let me explain this one in detail. This is an object which is at rest. This is object which is at rest. It will be at rest unless and until acted by some external force. Now I am applying external force. It will not stop as per this law unless and until again some external force will not stop it. This is first law of Newton. Newton's second law: the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of force. The rate of change of momentum will be changed and is directly proportional. That means when you are applying more force, the more momentum will be achieved and it will be takes place in the direction of force. Take example of your vehicle, automatic vehicle or a cycle. When you are pedaling a cycle fast, the momentum you will get will be more and will be in the direction of force. Third law, very famous law, to every action there is equal, opposite and simultaneous reaction. These are Newton's three laws which are very important as far as the study of mechanics is concerned. These are very basic principles of mechanics. Again, we have to remember system of units. There are number of unit system MKS, CGS and SI. We are going to adopt SI units, that is system international units. This system is universally adopted, accepted and approved, and we will use this unit system, SI system of units. In SI system, the unit of force is Newton. 1 Newton is nothing but 1 kg meter per second square, because force is nothing but mass into acceleration or mass into gravitational force. The unit of mass is kg and unit of acceleration is meter per second square. So, kg meter per second square will become in SI unit as Newton.